Hello everyone, welcome to the presentation of our KAI 2020 contribution See Feel Move, Player Behavior Analysis through Combined Visualization of Gaze, Emotions and Movement. My name is Günther Wallner and I'm going to present this work on behalf of all my co-authors. This work was motivated by the fact that playtesting of games often relies on a mixed methods approach to obtain more holistic insights about the player experience. However, triangulating the different data sources and visualizing them in an integrated manner such that they contextualize each other still proves challenging. Towards this end, visualizations and visual analytics tools have shown to be of great value for dealing with mixed datasets. However, visualizations integrating different data sources into one coherent representation are still few. In this paper, we contribute to this area by proposing a visualization tool that integrates movement data with gaze and emotional expressions. We have focused on these three because movement is considered an essential aspect in many games, not only providing insights on navigation patterns, but also offering spatial context for other recorded metrics. Emotions themselves, while recognized to be a vital part of player experience, have received almost no attention in the visualization of playtesting data so far. However, emotions might drive the decisions made during gameplay, and as such, emotions can serve as relevant contextual information for making sense of movement and other gameplay choices. Likewise, gaze information can provide crucial insights on, for example, how players make sense of the environment or if they are missing important items. Here is a short video on how the visualization looks like in action. The visualization itself is directly integrated within the Unity engine, allowing the user to observe the data in the actual 3D environment of the game. Here you can see the trajectory of a single player. Color-coded silhouettes around objects show how long players have looked at particular items. The duration is represented using a color gradient. Here, green indicates minimum and red indicates high duration. Tracked emotions can be inspected over time by means of line graphs in case details are of interest to the user. Secondly, particle systems within the 3D view indicate where changes in the emotional state of a player took place. The color indicates the type of emotion, while the emission rate of the particles reflects the intensity of the emotions. All three types of data can also be combined to get a more complete picture of the player's behavior. Here you can, for example, see all the data for one particular player. To evaluate our visualization approach, we conducted an expert study. For that purpose, we first created a small game and conducted a playtesting session with 12 players. This data formed the basis for the evaluation with the experts, in which 5 participants from the gaming industry took part. A session lasted for about 2 hours. After obtaining consent and demographics, the experts had time to familiarize themselves with the game in order to ensure that they had proper knowledge to be able to meaningfully interpret and draw conclusions from the data. After that, the visualization system was introduced to explain the functionality and navigation. The central part of the study required participants to solve different tasks with our tool. For example, they were tasked to find areas where players struggled navigating the environment or to find areas where players showed signs of surprise. Once all tasks were finished, the sessions were concluded with a final interview. From the analysis of the expert feedback, we could see that in terms of movement, the tool was considered very helpful for analyzing trajectories of single as well as multiple players. Especially the aggregated representation appeared to be helpful for detecting areas where a lot of back and forth took place. However, participants frequently used the individual view as well to inspect more subtle movement patterns which got smoothed out during the aggregation. In terms of gaze, experts consider it helpful to see that essential objects are getting recognized by the players. However, they also found it difficult to distinguish between objects which are looked at for a very short time or not looked at all. Here, a more distinctive visual representation would hence be needed. As emotions are imprecise and subjective, we opted for a more fuzzy representation through particle clouds. This was deemed sufficient by our experts. However, we also mused that not all visualized emotions were actually relevant for game designers. For example, one expert mentioned that contempt is much less important than frustration in a game design context. All experts were in agreement that combining all three data sources adds a vital element to the visualization, as it offers a more complete view on how players experience the game. However, at the same time, some experts also felt a little bit overwhelmed by all the information and were concerned that fine details are getting lost. As such, we can conclude that integrated visualization of different data sources helps to contextualize players' behaviors, but that careful design is required not to overwhelm the analysts and to turn the potential benefits into a disadvantage by obscuring essential information and details. And that's it from me. Thanks for watching.